Now let's start this video with a problem. A downward force of 100 newtons is applied to the small piston with a diameter of 50 centimeters in the hydraulic lift system shown below. What is the upward force exerted by the large piston with a diameter of 2 meters? So if we push down the small piston with a force, let's call it F1, the large piston is going to be pushed up with a force of F2. Now, according to Pascal's law, the pressure applied to an enclosed fluid is transmitted undiminished to every portion of that fluid. So what does it mean with regard to the hydraulic lift system? This means that the pressure exerted on a small piston is equal to the pressure exerted by the large piston. So we can say that P1 is therefore equal to P2. And pressure is defined as force divided by area. So since we're looking for F2, let's solve for it. Let's multiply both sides by A2. So here's the equation that you need. The output force, or the upward force exerted by the large piston, is going to be F1 multiplied by the ratio of the areas of the large piston with respect to the small piston. So if you exert a downward force on a small piston, you're going to get a larger upward force on the large piston. So the piston with the larger area is going to be associated with the greater force. And that's what you want to take from this hydraulic lift system. It's a force multiplying device. You can apply a small force on a small piston and get a larger force on the large piston. So let's go ahead and answer part A. Now the area is pi r squared because the pistons are circular in nature. Now we're given the diameter. The radius is half of the diameter. So if you have a circle, here's the diameter, and this is the radius. So F2 is going to be F1, which is 100 newtons, times A2, which is pi r squared. And the diameter of the large piston is 2 meters, which means the radius is 1 meter. Now the radius of the small piston is 25 centimeters since the diameter is 50. It's half of that. But we need to convert 25 centimeters into meters. So if we divide that by 100, that's going to be 0.25 meters. Now we could cancel pi. So 1 squared divided by 0.25 squared is 16. And 16 times 100 is 1600. So F2, the output force, is 1600 newtons. So that's the answer to part A. So let's move on to part B. What is the mechanical advantage of this hydraulic lift system? Mechanical advantage is the ratio between the output force and the input force. So the output force, the force exerted by the machine, is F2, which is 1600 newtons. The input force is the force that we applied to the machine, that's 100 newtons. So the mechanical advantage of this particular hydraulic lift system is 16. So if we were to apply an input force of 1000, this particular machine would multiply that input force by 16. So we would get an output force of 16,000. And so that's what the mechanical advantage of a machine tells you. It tells you what factor the machine will multiply your input force. So if we apply a force of 10 newtons, the machine is going to multiply that by 16 and exert an output force of 160 newtons. Now let's move on to part C. If the input force of 100 newtons pushes the small piston down by 2 meters, how high will the large piston rise? So we're going to push this down by a distance of 2 meters. How high will this piston rise? Let's call it D2. Now there's two ways to get this answer. The first way is to realize that the volume of the fluid inside the hydraulic lift system is the same. So typically there's some type of fluid inside this hydraulic lift system. And the change in volume in the small piston has to equal the change in volume of the large piston, because the volume of the fluid can't change. So therefore we need to say that V1 is equal to V2. The volume is the product of the area and the height. So V1 is A1 times H1, but we use D to represent the height. So you can say D is vertical displacement. So A1 times D1. And V2 is going to be A2 times D2. So A1, that's pi R1 squared, since we still have a circular cylinder. And A2 is going to be pi times R2 squared. So we don't need pi. We could cancel that in this problem. So R1, that's the radius of the small piston, is 25 centimeters, which is 0.25 meters. And then D1, we're pushing down the small piston by 2 meters. So D1 is 2. R2, that's half of 2, so that's 1. And so our goal is to calculate D2. So it's going to be 0.25 squared times 2. So D2 is 0.125 meters. So what does this mean? It means that there's no such thing as a free lunch. The machine didn't multiply our force by a factor of 16 from nothing. There was a cost, there was a price to pay for. Notice that the small force is associated with a longer distance, and the large force is associated with a smaller distance. So in order to multiply the force by a factor of 16, we had to pay the price by exerting the small force for a longer distance. And so the machine exerted a large force for a shorter distance. And so that's why the force was multiplied. The work has to be the same. The work done by the small force has to equal the work done by the large force, because energy has to be conserved. And so we could get this answer as well by using the conservation of energy principle. So the input work has to equal the output work. So the work that we apply has to equal the work that the machine will do if there's no friction. So this is the ideal situation. If this machine is 100% efficient, the energy that we apply to the machine has to equal the energy that the machine puts out as well. So the work done by the input force is just force times displacement, F1 times D1. The work done by the output force is going to be the same, F2 times D2. So we applied a small force of 100 newtons for a distance of 2 meters. And so the large force of 1600 newtons will be applied for a shorter distance of 0.125. So it's going to be 100 times 2 divided by 1600. And thus that will give you the same answer of 0.125 meters. So before we start this problem, you may want to pause the video to see if you could do it yourself. So we have a 1500 kilogram car, and it's placed on a large piston which has a radius of 4 meters. What is the minimum upward force that the large piston must exert to lift the car? Now gravity exerts a downward weight force on the car, which is mg. And the piston exerts an upward force, F2, on the car. So the minimum upward force that the piston has to exert in order to lift the car at constant speed is mg. If F2 exceeds mg, then the car is accelerating upward. But to lift the car at constant speed, those two forces have to be equal. So the net force is 0. So we can say that F2, the minimum upward force, has to be at least mg. So that's going to be 1,500 kilograms times a gravitational acceleration of 9.8. So in this example, F2 is 14,700 newtons. So that's the answer to part A. Now let's move on to part B. If the mechanical advantage of the hydraulic lift system is 20, what is the minimum downward force that should be applied to lift the car? So we know that a small force is associated with the small piston, and a large force is associated with the large piston. So if the mechanical advantage is 20, that means that the small force has to be 20 times less than the large force. So it's going to be 14,700 divided by 20. So therefore F1 is 735 newtons. For those of you who want to use an equation to get the answer, here's what you need to do. The mechanical advantage is the ratio between the output force and the input force. So we're looking for F1. So first let's multiply both sides by F1. So F1 times mechanical advantage is equal to F2. So now we need to divide both sides by the mechanical advantage. So what we have left over is that F1 is going to be F2 divided by the mechanical advantage, which is what we did. And that's 14,700 divided by 20, and that gave us an input force of 735 newtons. Now let's move on to part C. What is the radius of the small piston? So how can we get the answer to that question? Well, according to Pascal's law, we know that the pressure exerted on these two pistons have to be the same. So that means that F1 over A1 has to equal F2 over A2. Now I'm going to rearrange the equations. So first let's cross multiply. So first we have F1 times A2, and that's equal to F2 times A1. Now I'm going to divide both sides by F1 and simultaneously by A1. So on the right side, A1 will cancel, and on the left side, F1 will cancel. So what this tells us is that the ratio of the forces, F2 over F1, is equal to the ratio of the areas, A2 over A1. And we know that mechanical advantage is basically equal to the output force over the input force. The output force being F2 and the input force being F1. So we could say that the mechanical advantage is basically the ratio between the areas of the large piston and the small piston. And in this example, the area is pi r squared. So A2 is going to be pi r2 squared, and A1 is pi r1 squared. So we could cancel pi in this problem. The mechanical advantage is 20. R2, that's the radius of the large piston, that's 4 meters. So that's going to be 4 squared. And we're looking for R1. So let's cross multiply. So 1 times 4 squared is 16, and that's going to equal 20 times R1 squared. So we need to divide both sides by 20. So 16 divided by 20, as a decimal, that's 0.8. So 0.8 is equal to R1 squared. So now, we need to take the square root of both sides. So R1 is 0.894 meters. As you could see, it's much less than 4 meters. So that's how you could find the radius of the small cylinder, or the small piston, if you know the radius of the large piston, and if you know the mechanical advantage. Now let's move on to part D. What is the pressure exerted by the large piston? So pressure is force divided by area. So the force exerted by the large piston, we know it's 14,700 newtons. And the area is pi r squared. And the radius of the large piston is 4 meters. So it's 14,700 divided by pi times 4 squared, or 16. So the pressure is 292.4 pascals. Keep in mind, 1 Pascal is 1 Newton per square meter. So that's the pressure in the fluid. And that pressure is exerted throughout the fluid. So the pressure on the small piston is the same as the pressure on the large piston. Keep that in mind. And that's based on Pascal's principle. Part E. How far should the small piston descend? So we're looking for D1 if we want to lift the car by 2 meters. So D2 is 2 meters. The easiest way to get the answer is to use conservation of energy. So the work done by the small piston is equal to the work done by the large piston. Or rather, the work done on the small piston is equal to the work done by the large piston. So F1 D1 is equal to F2 D2. So F1, we said, was 735 newtons. And D1, we're going to push down the small piston by some unknown amount. We need to calculate D1. And F2, that's the large force, that's 14,700. And we know that D2 is 2 meters. That's how high the car is being lifted up. Now keep this in mind. The large force is always associated with the shorter distance. The small force has to be exerted over a longer distance. So D1 should be much larger than 2 meters. In fact, since the mechanical advantage is 20, we know that the distance that we have to push the small cylinder down has to be 20 times the distance that the car is going to lift up. So the mechanical advantage is the ratio between D1 and D2. So D1 is going to be 20 times 2, so it's going to be 40 meters. So you can also use this equation to get the answer. Or you could say 14,700 times 2 divided by 735, and that will give you the same answer, 40 meters. So there's multiple ways in which you can get the right answer. So now let's review some formulas that you want to keep in mind when dealing with the hydraulic lift system. The first thing is the mechanical advantage is the ratio between the output force and the input force. And it's also the ratio between the area of the large piston and the small piston. And it's the ratio of the distance that you have to push down the small piston by the large piston. So if you increase the area of the piston, the output force will increase. But the distance that the large piston has to move will decrease. So make sure you understand that relationship. And also, if you need to find the output force, it's equal to the input force multiplied by the ratio of the areas. And if the cylinder is circular, the area is pi r squared. And keep in mind that the diameter is twice the value of the radius. This is not the distance that you push down the piston by. So just make sure you understand that. And then the input work, F1 D1, has to equal the output work, F2 D2. And the volume has to be constant. So V1 equals V2, and the pressure is constant. P1 is equal to P2. And for volume, you can say that A1 times D1 is equal to A2 times D2. So there's a lot of formulas that you could use for the hydraulic lift system. And so if you want to write them down, here it is. Thanks for watching.